If you drive through the American Midwest, you will eventually find yourself surrounded by an ocean of green. Millions of acres across Iowa, Illinois, and Nebraska are dedicated to a single, relentless crop. Cultivating this massive footprint used to require armies of farmhands. Today, it is an exercise in precision engineering. A single operator and a GPS-guided tractor can map, monitor, and plant thousands of acres before the sun goes down. Every spring, specialized planters inject hundreds of millions of seeds into the freshly thawed earth, perfectly spacing each one to maximize sunlight and soil nutrients. Once the soil hits the right temperature, those seeds erupt. Fueled by summer humidity, these tiny shoots aggressively consume nitrogen and water, adding inches of height by the week. By late July, the transformation is complete. The fields form a dense, uniform canopy reaching 8 feet high, stretching straight into the horizon. Despite the staggering amount of land, water, and capital poured into this harvest, practically none of it will ever reach a dinner table as an ear of sweet corn. These fields function as a raw biological factory, feeding a massive industrial pipeline that extends far beyond the local supermarket. When fall arrives, the green stalks turn brittle and yellow, triggering a frantic race against the calendar. Massive combine harvesters rip through the fields, separating millions of kernels from their cobs in a matter of seconds. Farmers have a tiny window to get this right. If a sudden storm rolls in, the moisture content of the grain spikes. That forces the farmer to spend thousands of dollars on mechanical drying just to keep the crop from rotting in storage. The surviving grain is loaded into trucks and amassed into towering golden mountains outside regional silos. From here, the harvest splits into different industrial arteries. The largest pipeline by far is raw energy transfer. We feed the corn to livestock, converting cheap plant starch into dense animal protein. This grain is the lifeblood of the American cattle industry, packing quick, carbohydrate-heavy calories into beef herds before they head to the processing plant. The massive poultry sector operates the exact same way, relying on a constant supply of cracked kernels to sustain millions of broiler chickens. A map of the Corn Belt is effectively a map of the American meat supply. The Midwest's primary output serves as the foundational calorie block for the nation's livestock. The second massive pipeline bypasses the food chain entirely. About a third of the crop is trucked directly to industrial refineries for processing into ethanol. When you fill up your car at the gas station, you are physically burning a piece of the Midwestern harvest. Still, millions of tons more are chemically broken down. Refineries extract the starch to create high-fructose corn syrup, industrial adhesives, plastics, and thousands of other manufacturing ingredients. This chart shows exactly where the total annual U.S. corn harvest ends up. Notice how livestock feed and biofuel consume nearly the entire supply. Only a tiny fraction is set aside for humans to eat directly. This intricate supply chain props up thousands of businesses, but it is built on an incredibly fragile foundation. Every spring, farmers take out massive loans to buy seed and fertilizer, betting their entire livelihood on a crop that won't pay out for 6 months. During those 6 months, a prolonged drought can bake the soil into cracked clay, wiping out a capital investment before the plants even form ears. Or a severe summer windstorm can roll across the plains, snapping millions of stalks in half and destroying the harvest overnight. Modern farming is an extreme financial gamble. Every harvest depends on a fragile alignment of local weather patterns and global commodity prices that can shift in a single afternoon. To survive those odds, modern agricultural operations are leveraging data science to squeeze every possible ounce of efficiency out of their land. Autonomous drones run daily aerial surveys, scanning for nitrogen deficiencies and instantly applying targeted treatments to individual sections of a field, rather than blindly spraying the whole farm. The modern farmer spends less time turning wrenches and more time analyzing yield maps on a tablet, calculating exactly how much moisture a specific acre holds. Because they can manage the land with such incredible precision, this single plant species remains abundant enough to be engineered into everything from the meat in your fridge to the fuel in your tank. Though we rarely see the raw kernels, this single plant has become a primary, invisible building block within the infrastructure of the modern American economy.